Hello, welcome to the Machine Learning at Home. Today I will speak about neural networks, the famous and extremely popular method of machine learning. It is easy enough to demonstrate how it works, so let us load the library first. That library should be installed together with R, so you shouldn't install it separately. Simply type library nnet. And now we need to prepare iris train subset from iris data and iris test subset from iris data. Okay, and now we launch the actual nnet function. So make an object iris nn, for example. We'll run function nnet, and that function will use the same formula interface. Species against all other variables. Data will be equal to iris.train. And we need one more parameter. We need the size of intermediate layer. So for example, size will be 3. The library nnet will allow you to use so-called feed-forward neural networks, very simple variant of neural networks. And neural networks is, well, nothing more than just a system of equations. So nnet function will find coefficients. Let me show how it works. You see, this is a stepwise process. Initial value of something, it's actually value which represents the error rate, will be high, and then with each step this error will be lowered until it will be finalized in some value which is close to 0. We can look on the model itself. So this is a 4-3-3 network. 4 is a number of our initial characters. 3 we set here as a size equal to 3. And 3 at the output are our 3 species. So this is how it works. We can also say summary of iris nn, and it will show us all nodes of that system of equations. So all these equations are connected together, and you can see how they exactly connected. You can also plot it, but I will leave it for some of our future meetings. Now we go to the prediction step. So we specify our output object, and it will be result of prediction function, predict, from our model. And also we need to use new data, iris test, without character number 5. Okay, and also I would like to add one more parameter, the type of prediction. Type of prediction will be class. And now we can make a table of our actual species labels, which is column number 5, and our predicted species labels. So I would say it is very well done. So only 4 of versicolor are predicted badly. So this result, to my view, is even better than LDA. So very nice. And this is, by the way, why neural networks are used so extensively. So neural networks can go with extremely good prediction of very complicated data, and it's a simple network we use. So more complicated networks will work much better, but slower, of course, anyway. So neural networks have embedded method to understand the class probability, how well each observation was predicted. Let us use it. So then we should repeat our prediction step, but specify another type, row. and then I would change the name to pred2. Okay, and then I will access Aris NN pred2, and I will access rows from 60 to 70 to see how well that they predicted. It's good also to round these numbers with, for example, 3 digits. Okay, so as you see here, row number 78 was predicted not very well. All other rows are predicted much better. So, well, neural network has one particular big minus. It's a black box. So it is not clear how it works. So it works how you train it and how it went due that period of stepwise convergence algorithm. So if you train it well, and if that convergence process went well, then probably it will work well. But there is no way to understand which of, not direct way, I would correct myself, to understand which of features, which of characters work better. There are some indirect ways, and we might learn them later if you like. Also, neural network is stochastic method, so results of it are maybe somehow random. Let me show it. For example, we run that same NNet again. Okay, now by the way, the process is longer. We need to run our predict in type class, and now to run our table again. So the results are different now. They actually significantly worse. So 8 rows were predicted not so well. So you see, results are stochastic. Each time you will have slightly different results. That's a second big minus of neural networks. Otherwise, they work extremely well, universal, many different types of data, and with complicated networks you can allow it to classify very complex things, for example, images. That's very typical thing for the neural network. I don't use images in my example because it will be much longer. So each image consists of multiple pixels, and this may be the hundreds, thousands, and billions pixels. So each of our 150 rows will consist of billions of numbers, which will slow down the work significantly. But you can, I hope, believe that it might be possible. So that was a neural network, and how exactly they will work I will probably also explain in the future, and we'll try to create some neural network, simple of course, neural network models manually. Anyway, this is it for today. Thank you very much.